Hey there, this is part 3 of a tutorial series where I'm integrating Lyra with the SneakyKitty game shooter framework. It's a framework that you can get on the Epic Marketplace that has an incredible amount of C++ backend code that allows you to create, and it's super modular. It allows you to integrate true first-person shooter logic into your game, and has an incredible set of weapon attachment logic, has projectile spawning logic as well, projectile calculations and things like that, which we can get into in future videos. But for now, what we're doing in this next video or two is just getting the true first-person shooter perspective set up with Lyra. As you know, Lyra is a third-person shooter game, and it's heavily oriented towards third-person shooter camera behavior, and so one of the things we'll have to do right off the bat is change the camera. But let's show where we are now, just as an overview of what we're doing. So if we go ahead and play, okay, so you'll see we'll start here in this default experience. So let's go ahead and stop, escape out, stop, and go to editor preferences and go to maps, or project settings, sorry, and go to maps and modes. And let's change this to our test map that we made earlier. So where is that? It's my game level, and so we'll default to my game level, and game default map will be my game level as well. Okay, great. So then let's go to the content browser, go down to our plugin. Here's where we created our last plugin here. Go to maps, and let's load this level so we can spawn our character. And this is the level that also has our gameplay experience associated with it at this point. So let's spawn into this level and show you kind of where we're at. Okay, so you can see we're in third-person mode, but we're doing this from our own game feature plugin, right? So this is our own game feature plugin. We're not using Shooter Core. And the only abilities that we have, I think last video I said we have just jump, but I forgot we actually set up crouch as well. So we have crouch and jump. And right now it's just toggle crouch. I can show you how to do a hold crouch. But yeah, so those are the only things we have set up right now. So these two things, crouch and jump. Great. So that's where we are now. But we have, and we don't have any of the menu stuff set up. So if I push escape right now, you'll see nothing happens. So I'm having to shift F1 and stop. But we'll add the UI layer to this as well to make that a little bit easier for us. But for now, let's get the first-person kind of logic set up. And like I mentioned before, Lyra is an incredibly powerful framework, but it is very third-person centric. And so I'm going to go ahead and just stop the editor real quick here. I like to save all, and I'm just going to stop this in Writer. I'm using Writer. You can do any of this in Visual Studio. It's not a problem. So yeah, so if we look at the Lyra directory starter game, and we look at the code directory, we look down here at camera, you can see that Lyra uses these camera modes, and the camera mode third person is what it defaults to. And in fact, that's what we set up in our other tutorial, to use this camera mode, which then finds a third person curve offset that it will then use as a starting point. The camera manager is, it grabs whatever camera is created in C++ and starts managing that camera with a camera mode right off the bat. And just to get going here, instead of creating our own camera mode, we're going to do something else right now that's a little bit hacky, but it will get us to a first-person shooter perspective pretty quickly. If there's time and if I can figure this out, we'll go back and create our own camera mode that's first person. But for now, I haven't found any drawbacks with this, but it does mean that we're going to modify Lyra code, which is something I don't typically like doing. But in this case, since the character has the constructors, if we look here, since the character implements and then constructs the camera as a default sub-object in its in the first part of its creation, there's no way to override this functionality. We can't override this because it's happening during the creation of the class, right? So since you can't override this, there's no way to stop this from happening. And what I've found, even if you did do that, is if you were to create, remember we created our own character class in an earlier video. even if you were to destroy this camera and then respawn a new camera and try to take control of it, Lyra's camera manager will grab it and use the third person camera mode as a default in order to manage that camera. So until we can get to a place where we can build our own camera mode and get around the third person camera mode, the fastest and best way to do this, which isn't very destructive if we're assuming we're making a first person shooter game, at least initially, then is to just stop Lyra from doing this with the camera, stop Lyra from creating a camera, and then add our own camera in blueprints. So the way we're going to do that is very simple. We're just going to look for where the camera is declared, and then we're going to find where the camera is created, which we just saw. So let's find our camera. So here's our ULyra camera component. So I don't like deleting things, so I'm just going to comment out these two lines. And then in our Lyra character, you can see obviously, since we haven't implemented it, we're going to have to comment out these two lines. So now Lyra will not create a new camera for our player character across the board. And that will allow us to add a camera and do with it what we will. Okay, so yeah, so let's go ahead and compile this code, and we're gonna see what the result of that is right now. So okay, so we built successfully, and there were no errors. And so yeah, so if we look at our BP hero my game, this is once again the hero at the end of the parent-child relationships that goes from character default all the way through hero default and then into my own character based on hero default. We did that in one of the first videos, got up to there. You can see now that because everything is still parented initially from Lyra character, that when we make this character now, we do not have a camera. Okay. And so since we don't have a camera, what Lyra's camera manager built in Unreal's camera manager is going to do is look for is going to create a camera for you. You can't it'll do that for you regardless, because otherwise you won't have anything, you won't be looking through anything, you'll just be a black screen. So but it's going to use the camera mode that we set up in our data asset for, I think it's our hero pawn data asset, yes. So in one of the earlier videos, we set up this CM third person, this camera mode third person, right? So this is the camera mode blueprint class that is based on the C++ class that we saw a couple seconds ago, and it's this third person offset curve that is kind of defining where the camera is going to go in space, okay, relative to our character. Okay, so so if we play right now, you'll see we get kind of odd behavior where the camera spawns in behind the character a certain distance, and you know, our character is still orienting to the movement, but the camera is its own independent object, not attached or associated with the mesh, right? So this is kind of the default camera that's being created by Unreal Engine that is nothing to do with the camera that we would add to the blueprint, because we haven't added one yet. So let's go ahead and add a camera. So the camera wants to be attached to the mesh. So we're going to add a camera that's attached to the mesh, and we'll call this camera FPS camera. At some point we may want to create a third-person camera that we can transition out to for a third-person view as well. But for now, let's just start with FPS camera. And we want to attach that to the mesh. So if we go to the mesh and then find the skeleton, right? So the invisible skeleton is fine, or you can use the SK mannequin skeleton. So let's just go in here. Okay, so we're going to go in here and let's just go ahead and add a socket where we can attach the mesh. So let's add a socket to this head, and let's call this S underscore camera. Oh, let's call it S. Yeah, let's just call it camera. Cool. Okay, so once we save that, then we come back to our hero and we take the FPS camera. We can now attach it to that socket. Okay. So if we go into the viewport, you can see the camera is socketed here, okay? And so the orientation of that socket is determining which direction the camera is facing. So what we really need to do is go back to our SK mannequin, look at this camera socket, and position it here in the skeleton to get what we want from the orientation. and it's X forward and Z up. So, so we go to W. You can see right now it's Y forward and Z up, and we want this camera to be roughly where the eyes are, let's say, or clear of whatever head geometry you might have on your character. So in the end, if your character has kind of some extra stuff on here, you'll want this socket to be clear of that geometry. And so let's go ahead and rotate it. So we're going to need to rotate it 90 in this direction, and then we're going to need to rotate it 90 in this direction, right, to get X forward and Z up. Okay, so if I save that now and I come back to my hero, you can see that that's where the camera is now. And make sure that all of these settings are default, otherwise they will add to whatever that baseline is. And you can manage it from here as well, but I typically manage it from the skeleton. Okay, so that's that. So our camera is now kind of attached to the mesh, and so let's go ahead and spawn in and see what we get here. So now you can see that the camera is attached to the head, and we're using its control rotation, so we're still getting turn in place, but we're not really able to look up or down. And so let's fix that problem. Let's go back to our hero, select the camera, and if we look for rotation, use pawn control rotation, compile, and play again. Now you can see we can look kind of, as our controller is trying to look around, we can now look kind of in all directions. Okay, so we can look down at our body, we can look up, we can look all different directions. Great. Okay, so now we have a camera on the head, and it's there, and we can see the first person body down below us, and all that stuff. So we're good. We can move, we can jump. All that stuff is working. Crouch. The camera goes with it. So yeah, so we have all that kind of functionality built in with the camera just being on the head. Okay. But you'll see that the camera is moving quite a bit here. It's kind of subtle, but it's moving with the animations of the whole body. And in a first-person shooter, you might want that in some places, but for the most part, you kind of don't want the upper body to be affected by the lower body. And so we'll get into that in a second. But yeah, so that'll lead us now into kind of the anim blueprint stuff that we need to do to kind of get this to work. So let's take care of that stuff now. Okay, so if we go back here and we go back to the mesh, we can find the animation blueprint that we're using as a base. And what we want to do right off the bat is just duplicate this and call it our own thing. And we can leave it here in the top level, meaning to say in this primary directory that we talked about before. I'm going to call this my game because that's my game. And I'll just give everything that is associated with my game this suffix so that we can find it easily when we search all that stuff. Okay, so we want to be using this one, right? So this one is obviously a duplicate of that, so it's the same thing, but we want to start copying and doing our work here, not on this one. That way, if this ever gets updated or replaced, we can look at the changes and we know we're not going to break what we have. This is going to be its own independent thing now. So let's open it. You'll see that when we go to talk about the linked layers, that we're going to do something a little bit against what I just said, but for a reason in terms of expediency, and we'll talk about that in a second. So if we try to compile this, you're going to see something right away. We're going to see we're going to get errors right away, right? So, we're getting these errors because ADS, weapon fire, reload, and dash don't have tags associated with them, and that's pretty standard for this. So let's fix that now. So if we go into gameplay tags and property mappings, you'll see there are several mappings down here that need to be set, and right now they're all empty. So it's pretty easy because the tag is telling you what it wants, and so just give it kind of what it wants. So event movement ADS wants this gameplay tag is ADS, so we'll give it that. Weapon fire wants is firing, reload once is reloading, right? So when the movement and reload tag is set, the gameplay tag is reloading is set, then event movement reload is flagged or activated, and then the anim blueprint will respond accordingly to how that variable is set. So tag is this is the tag to map onto this um, onto this variable. So dash is going to be is dashing, right? Okay, so then and then melee is melee. Great. So it's pretty straightforward. Great. Okay, so if we compile now, okay, you'll see we don't get any errors. So now we have a duplicate that works. That's kind of a basic functioning kind of anim BP. But you'll see something right away here. So if I do what you would think you would do next, which is to say, well, let's just go ahead and give our character this new anim BP and just compile. And let's go ahead and let's play, right? You're going to see we don't have any of the movement stuff, or it's really kind of wonky and almost broken, right? So it gets really erratic and it's kind of crazy. So what does it mean? Okay, so if we look up top at the log, you can see that it has to do with item anim layer space ABP. And so what we need to do is we need to change that, and I'll show you what we need to change in that. So Shift F1 again. We'll put the UI in there so we get the menu so we can escape in a second. But let's go ahead and fix this so we can get this working. Okay, so we go back to the content browser. This is the main anim blueprint, but you know the way that Lyra is set up, and this is the way that Epic, this is the way that their animation chain is kind of, you know, the new way that they do it is through linked layers. So this ABP item anim layer base, this is what holds all of the layers for the different states that you want to be in. So all of these anim layers are logic layers that kind of you would normally see in the old way in a regular anim BP, but this time they're broken out to different layers, which makes it more modular and allows you to add layers or not use layers as you see fit, and to swap layers at runtime or and manage this you know, very complex anim BP kind of in a more modular way. So so that's why we have these anim layers. Now the error we're getting has to do with the fact that if we go to get main anim BP thread safe, we're casting back to the old ABP that we just duplicated. So this is not going to our BP, it's going to the anim BP that we kind of unlinked from our character by duplicating it and setting it. So we just want to cast this to our own anim BP that we just duplicated. So if I do cast to ABP, and I just look for ABP my game, right? Then all I have to do is this, and well, we need to do a couple more things, but just so we have clarity here, I'm going to delete. I'm going to delete this, right? And you'll see that the return node here, the return value we want to return here is going to be this, and we can't put that in there, right? So why can't we put that in there? Because the return value is actually a variable of the type that we just got rid of. So we want to change this to ABP underscore NMBP my game, and now we can do that, right? Okay, and then we want to go right. Okay, so if everything fails, just return, and then if we do get this anim instance to be valid, then we go through the return node sequence there. So compile that. You're going to see we're going to get some more errors, right? So why are we getting these errors? So the reason we're getting these errors is because we have a bunch of property nodes that are still accessing the old um, uh, variables from the old NMBP base. So we want to, yeah, we want to make sure that we, sorry, and I had this hooked up actually incorrectly. So we want to return here, and if cast fails, we want to do this and say, basically print this log string. So, and return node here, the value of this return node should also be switched. So let's just do that real quick, sorry. So my game, right, and it defaults to object, and then, actually no, so we just return nothing. That's fine. So compile that. Okay, great. So let's find these errors here, okay, and we're going to chase all these down. So go to property access, you'll see get NMBP thread safe. This property access node is looking for it there. So let's go ahead and just create our own property access node. Property access nodes are, so get NMBP thread safe. Yeah, we'll just get this one here. So we're there, right? Get main NMBP thread safe and delete that. Compile. Got rid of that one. We need to get rid of this one as well too. So property access. Okay, so what we need to do is just pull off of here and set last pivot time from this thread safe, and we can just set the value here to 0.2 so that we're in the same place, and then delete this and redo this. Great. So now, yeah, that variable is being pulled off of that one, so compile that. Great. So we're still getting errors. So let's find the next error. The next error is input placement. Okay. Oh, it's just telling us that node's experimental, sorry. So can't connect these values because again we're getting NMBP thread safe and they're getting the wrong one. So we just need to do that. So we need to get NMBP thread safe. Okay, and then from here we can, what is this? This is the world location. So we're going to get world location. So get world location and then split this pin, and we will just remove this and add in this. Great. That's gone. That's there. Compile that. Okay, no error there. Property access again. Once again, we have another property access node here that we need to fix. Okay, so just follow the errors, and we'll do basically it's the same thing over and over again here. Pretty simple stuff. Yep. So get cure value is going to be. I wonder if we're able to put this here. So if we can say is this valid, that's good. And then can we just get this one here? We can. Did we miss something? No, we did not. Okay, so yeah, we can do that. So compile that, and we don't get an error there. We can delete this. And that's experimental successful. Great. So why is it saying we have warnings? Nope. Okay, we're successful. Great. So that's it. So we went through and chased down all those property access errors and got rid of those. And so now our item anim layers base is now associated with our our own anim BP base my game. Okay. So you're going to ask, why didn't I duplicate this? Okay. And there's a reason I didn't. And you know, trust me when I say it's easier not to, because the question becomes, well, okay, Lyra gets updated, let's say by Epic Games, and always the question is, well, so then what do I need to do to get my game back up to get my game back up and running, and how much work do I have to do my game to get, how much work do I need to do to get my game up and running again if Lyra updates, and if the update is worth updating for. And when you duplicate this, it needs you to, it will prompt you to basically, um, it will collapse all of these layer functions, these logic functions, into, um, it will basically decimate these. These will go away. So you need to recreate all of these in its own anim BP layer state, because there's no way to really copy all these, or rather, it's a lot of extra work to do that. So it's actually easier to just do what we did again in the future if it's updated versus doing what I just described. So yeah, so that's why we're doing that, and so we're not duplicating this, because we'll lose information from this that we then need to rebuild, and the information that we would need to rebuild is so extensive that it would just take a bunch of time to do that, and it's just less time to do what we just did again if Lyra gets updated, and that's the approach that I'm taking. So that's why we didn't duplicate this. Okay. So yeah, so then there's that. So now when we go back and play, I believe we should get both movement and also no errors, right? Yep. So now we're back to a functioning, moving character, with all the things we need, and no warnings, no errors, and no glitches. Okay. So that's how we get to that place. Okay. Great. So now this is AnimBP base my game. Okay. And if you're not familiar with the way that Lyra works on the AnimBP side, it's very complicated, and so I don't think I'm going to have the time to go over all of the abstract concepts behind the way it works. Frankly, because it's so convoluted that I haven't explored every little nook and cranny of this thing. However, you'll notice that your event graph is empty, and that's not typical of the old way of doing things. You would normally put a lot of things here. Your event graph is empty because most of your functionality that would go into an event graph within your anim graph is now on the thread safe blueprint thread safe update animation function, which is now standard in the AnimBP. It comes with it's a built-in function, and all of your getters and setters that you would normally have in your event graph on your AnimBP are now in this thread safe function, and these are all thread safe functions. I'll link a video from Druid Mechanics, Stephen Ulibari, that goes over how to do this. He's one of the best teachers for Unreal Engine that is out there. Highly recommend his courses, highly recommend his YouTube videos, and he goes over kind of how to, what this is, how to do this, how to set this up. But the short, the short answer of it is basically these are all thread safe functions that always return a, that all of these functions are marked as thread safe, and the reason that they're thread safe is because if they have a return value, which this one doesn't, but if they do have a return value, that return value is named a specific convention. So there's a couple steps you have to go through to get a blueprint thread safe function, and so he goes over that in his video, and I'll link that video in the description of this below. Okay. Anyway, so that said, our blueprint thread safe update animation function is doing all the getting and setting of variables that you're probably used to in the typical event graph, but that's all happening here in blueprint thread safe. Now, because that's happening here in blueprint thread safe, that means that we have to get properties in a safe way, and that's what those property access nodes are. Those are used for us to get these properties in a safe way, running on the game thread that's timed in a way such that the game thread itself retrieves the variables when it's appropriate and when they've been set relative to the other things that are happening, and it's determining when the best time for that is, and then returning returning that variable in a way that is not interrupting the game thread. So this is a much more efficient way to have animation operate, and it allows for a much more complex set of, again, linked anim layers happening that don't know who's communicating with what, because they all live in their own separate um, NMBP layer files, and so they can all kind of grab things when other things aren't being grabbed by them. So the same variables can be grabbed, and queued relative to each other in a way that's safe for the thread and doesn't cause backups, bottlenecks, and potentially crashes. So that's why the blueprint thread safe update animation function is important when you're using these anim layers in order to create much more complicated or sophisticated anim BP graphs. You need to be able to grab the variables. Each of these needs to be able to grab the same variables to operate, but in a thread safe manner, and that's why this is there now. Okay, so that's a quick understanding of what this is and what that is doing. Okay, but if we look at the anim graph, that is not empty. So the anim graph, the primary anim graph, is not empty for Lyra, and it it gets complicated, right? Like this is a very complicated locomotion system in Lyra. However, if you've watched my other tutorials on integrating SKG SneakyKitty Games shooter framework with smart locomotion, you'll note that even the most complex locomotion, or anim blueprints typically end up doing one thing somewhere in the anim graph, which is to say they end up splitting lower body from upper body, right? And that's usually done in this layered blend per bone node, and you'll see that across the board in most anim blueprints. This layered blend per bone is taking whatever's happening in the upper body and blending the lower body stuff, which is, of course, once again, very complex, using state aliases to jump between things so there aren't all these lines crisscrossing each other. And in each of these, we've got a whole linked anim layer linked in here with a blend space and all the stuff that happens within these states. So all of that complicated stuff that's happening in here is basically going into this cache pose, having additive upper body things that are applied to it, and then being basically blended together with the upper body stuff, which is its own thing, or can be separated and then blended together here. So as complicated as all of this is, it's still actually pretty simple when you think of it that way. Lower body, upper body, blended together, and then going through and using these full body aiming skeletal layers, which we are going to get rid of. Remember, Lyra is a third-person centric framework, and so it is able to get away with a lot more animation massaging, or like layering and stuff, because it for the full body, because it is a third-person game. You're looking at the character from afar. You're not actually kind of inhabiting the character. The character's not there. And SneakyKitty Games Shooter Framework has all the procedurals required for us to do all that super precise procedural aiming, and we're not going to use any of this for that. We could bring this back if we do a third-person mode, which we might do, but for now, just getting first-person set up, let's get rid of this and make this less complicated, right? So what are some of the first steps that we need to do to get all of this working together? So the first thing you really do need to do is you need to bring the SneakyKitty Games example framework project into your project, okay? Because there is something there that we need. All right, so I'm going to do that now. Pause the video, and I will show you what I did when that's done.